So this is the DITEX CarScope Plus, and we're going to take a look at it today. So what it is a 4-channel oscilloscope. Okay, this is the oscilloscope here. You can see we've got the 4 channels. And what makes this oscilloscope different is that it's not a USB oscilloscope. So it's connected by LAN. So you can see here in the box we've got the LAN cable, and we've also got a separate power supply. So on the back there you can see we've got a LAN input and the separate 12-volt power supply. So all we need to do is either get a separate 12-volt battery to connect it up to, or simply connect up to the car that you're testing. Now, the benefits of connecting to the oscilloscope via LAN rather than USB is that you don't get any interference from the mains power supply or the laptop. So I've done this test a few times, and if you check the resistance between the Bnc negative and the earth lead of the 3-pin plug, there is actually some connection there. So by using a LAN, I think they called it galvanic isolation. So that means that the 2 sides aren't physically connected. So it's a similar principle they use in inverters on high voltage electric vehicles. So that would be from the high voltage side to the 12-volt side. You also get 4 cables for connecting up to each channel. One of the cables has got 2 connections on. So you've got the black lead for the ground connection and the red lead for taking your measurement. And the other 3 leads just have 1 connection on there. That's because this oscilloscope has common grounds, so all you need to do is connect up 1 ground and then it uses that across all 4 channels. This does use Bnc Connections, so any adapters that you've already got for Bnc, like amp clamps, pressure sensors, maybe you've got some test leads from another manufacturer, they will also fit on this as well. Another interesting component that you get is this AC coupler. So if you want to measure things that are in AC, or you want to couple to AC so you can use a smaller voltage scale to see the detail of the waveform, then you simply connect this up. And I've not actually seen one of these before, so we'll give it a go and see how it works. Okay, so we are all connected up here. I've got the 12-volt power supply and the LAN connected to my laptop. And you might be able to see on the front there that you've got a green light indicating that we've got some connection on there. I've opened up the CarScope 3 software. Now, you can download this from the DITEX website. You do also get a disc with the oscilloscope. However, I'm not quite sure what version of software that is. The guys at DITEX have been working on this new version software, so they've been sending through updates regularly. So you can see here that we can opt to see a demo mode, so you can go and download the software and give it a go for yourself. If we just hit play there, you can see that we've got a waveform up on the screen. However, what we're going to do is connect up to some real signals using the snap-on scope demonstrator board. So this creates a few different waveforms that we can actually test with the oscilloscope from the comfort of this office. So all I'm going to do is hit that disconnect button, click connect, and we should now be on our oscilloscope. So we've got a 20-volt scale set up there, as you can see in the top corner. So I always like to just check the oscilloscope on the battery first to make sure that everything's set up and connected and working. Okay, and we can see there we've got a flat line at 12 volts, so we're all connected up and ready to go. Okay, so it looks like we've already got a trigger set there, and we can see that the waveform is being held here. However, we're not getting the full square signal on the screen at the minute. We can see the time setting down here is set to 1 millisecond. Now, 1 millisecond time scale is really quite low, or fast, if you like, for most automotive waveform. So I generally like to start at a 20 millisecond time scale if I'm not sure. So now you can see that we've got this pulse width modulation on the screen, and I'm just adjusting it there and we can see it move. This setup is quite similar to a lot of the other oscilloscope softwares that are out there at the minute. I've not spent much time with this software. had a little play with it, and it is actually quite intuitive and easy to use. So let's take a look at some of the basic settings. So we saw the time setting here that we could increase and decrease. It is a 20 megasample oscilloscope, so you can see that it's having no problems picking up this waveform here. Even if we go up to a higher time scale there, like 500 milliseconds per division, that's half a second on the screen there, it's doing absolutely fine. So I'm just going to go back down to 100 milliseconds there, and we can see that we've got a 5-volt signal on the display. So what I'm going to do is decrease that voltage scale. Okay, that's probably okay there. Now, something that I do like about this is that we can either move that up and down by going to this 0 line here. And what we can do is drag that down so that we can see the rest of that grid there, also known as a gradicule. So what we've got here, look, is bipolar. So if we click that, what it does is moves that 0 line down to the bottom. So if you're only looking at DC waveforms that go above 0, this is a really good way to change the oscilloscope so you use the full display. So I quite like that. Most of the oscilloscopes I use, I'm quite used to looking at it with the 0 in the middle and then all this wasted space down the bottom. So that is a nice feature. Another great feature is the invert button here, so you can quickly flip it upside down. You might want to use that if you are using an ignition clamp, or if you are using a amp clamp, and let's say you get it the wrong way round. Sometimes the amp clamps are quite difficult to get in, so rather than struggling to move the amp clamp, you can just hit the invert button on this software. Really useful feature, and I use that a lot. And the other mode here, Zpl, we'll come back to that a little bit later, but you see if we click it now, it doesn't really do anything. This is going to make more of a difference for when we've got nothing that touches the 0 line like we have here. So you can see here, this comes down and touches the 0 line. So we'll take a look at that feature in a moment. With the trigger settings, you can see if we turn the trigger off, then the waveform starts moving around. Selecting the trigger there, it looks like we've already got a trigger level here. So what we can do is move that trigger level down, and if we move it below the waveform, you can see that we've lost the trigger and it is now moving around. So that's quite easy to set. So that's trigger level there is that dotted line that goes across. This vertical line then is our trigger position. So if we wanted to move the trigger position to the center, we could move it across there, and now we're triggering here. Another nice feature you might notice is if you see as I move down the screen, we've got this little yellow dot that follows the waveform. Okay. Now, if you look down here, that yellow dot gives us the measurement that's been taken at that point. Okay, so you can see now we've gone up, it's 4.979 volts, and it also gives us the time figure as well. So if we go into the 0 line there, where the trigger's set, it's around about 0. So that's another really nice feature to get live measurements on the screen, and you can see we're doing that and the oscilloscope's actually running. If we stop the oscilloscope, we still get that feature up there. Okay, you can notice now that when we pressed stop, we've now got the zoom feature here. Okay, so I've had a little play around with the zoom feature. If we click on this first, what we get is this shaded area, and we can actually change the size of this shaded area. So let's say we wanted to zoom in on this peak here. We just zoom in on there, hit that zoom, and then it zooms in to that area that we selected. Okay. If we click that again, we get another zoom kind of area come up, and we can do the same. Okay. If you want to then go back, you just hit that minus and you can go all the way back. Or if you wanted to just cancel the zoom that you made, you can just cancel it off. I think if we've selected our zoom area like this and zoom in, we can then use this little window at the bottom to actually move that along, and basically it will just try and move to where that mouse cursor is. So just turn that off there. You can also see here that we've got a waveform buffer. Okay, so buffer memory, what that does is saves the screens as we record them, so we can then scroll back through them, and you can see there's quite a huge buffer memory there. I'm not sure what the maximum is, but that just went up to 1,000. And we can also then save that waveform. I'll just save that as PWM. And if we wanted to, we could then open that waveform and take a look at it again. Okay, so now I've got a camshaft and crankshaft waveform on here. You can see that we've got the crankshaft waveform up at the minute. We have got a trigger selected, but it's having a hard time holding it still because it's not the same all the way across. Of course, the trigger only triggers to the point at which the voltage rises above the point, because we've got that positive rising edge trigger selected. You can see there we have got those other trigger options on there. So what I'm going to do now is turn on channel B, okay, and now you can see that we've also got that crankshaft waveform selected, okay. And what I'm going to do is also put on another channel for an injector. So let's turn on channel C. 20 volts isn't going to be enough, okay, so we can see here that we've got channel C now active. What I'm going to do is trigger to channel C, because that should hopefully hold still. Let's just find that trigger level. Okay, I'm just going to increase the voltage on channel A to make that a bit smaller, to give us a bit more space. Move that up there. And then I'm going to move channel B up as well, and just click on that side of the waveform and move that up there. And we can see that with the injector selected on the 20 volt scale on channel C, it's clipping the top of it. Okay, so let's just increase that voltage. Okay, that's the highest it goes, so 20 volts is our limit. What we're going to have to do is connect up the attenuator, and if we now go onto the channel and select the 20:1 attenuator, we should now get a reading that is relative to the attenuator we've selected. If we go down now, just move that down to 100 volts. Okay, so what are we going up to? Around about 50, so we can afford to bring that down another level there. So now we can see that we've got the injector selected here, and we've also got the camshaft and the crankshaft. Okay, so really nice waveform that we've got there at the minute. Let's just save that and zoom in. Okay, we can also select an area. I'm just going to select this area here. Okay, so now we've got a couple of injections on the screen, and we can see that we've got the camshaft at the top and the crankshaft here. So one of the great features that you get in the DITEX software is the rotational rulers. Now, rotational rulers are quite important if you want to measure camshaft and crankshaft timing. Okay, you can do it without them, but it usually involves counting the teeth. You can use the time rulers, however, it's not always quite so accurate in case the two engines are doing a slightly different speed. The time distance between the two is going to be different, not necessarily indicating a timing problem. So what we need to do then is try and get these as close as possible. Okay, so we've gone on that edge there, and we've gone on this edge here. And what we can then do is use this ruler here to measure the reference point on the camshaft. So you would need a known good reference waveform for this to work. What you would then need to do is do that same measurement on the reference waveform. I'm going to save this reference waveform, and you can actually download it and have a play with it yourself at mechanicmindset.com. So click the link in the description to sign up and access and download the free waveforms. You'll also be able to access that free training that we've got on there and see what we are offering at Mechanic Mindset. So that's a quick look at the rotational ruler. It's also really useful for things like in-cylinder pressure diagnostics as well. Okay, so that was the rotational rulers. We have also got some normal time rulers here. So just selecting that millisecond button there, we can go ahead and measure the time distance. Okay, so this is the injection duration. You can see there that we've got a difference of 3.8 milliseconds, so that's the time that this injector has been activated. And another thing I want to show you is the different capture modes. So what we are on at the minute is the lab scope mode. Here we've got this continuous mode. This would probably be useful for measuring voltages over a longer period of time, possibly for things like pressure sensors, voltage supply, maybe even relative compression. So what I've connected up to here is a pedal position sensor voltage, and you can see I'm moving that up and down and it's recording that as we go. Okay, so all we can do here as well is increase that time that it's recording. Okay, we can also reduce that voltage scale so we use more of that waveform display. Okay, even again we could go ahead and change that to turning off the bipolar, so we're using that full oscilloscope display. So I'm doing that quite quick there, and I think that would be more than suitable for measuring things like relative compression. Again, we can pause and then zoom into the areas that we want to look at in a bit more detail. We've also got this automotive tab here. So what it has is loads of presets for your different sensors. So if you just go ahead and click on that crankshaft position Hall sensor, what it does is sets up the oscilloscope ready for you to take a measurement on that sensor. So this is really useful if you're not sure what kind of settings you want. And you can see there that we've got quite a lot of different settings in here for you to take a look at. I also really suggest you go and check out autoditex.com. This is the DITEX website, and you can see here that we've got a library, and what they've got is basically a large library of how all these different sensors work, and also how to test them and what you should expect for an oscilloscope measurement. And there is just loads of information in here, really useful stuff. So this is for secondary ignition coil testing. What we've also got in here is lots of preset probes. So if you have already got some amp clamps and things like that, there's presets in here for that. We've also got the presets for the ignition pickups and pressure sensors. So I've got, for example, one of the DITEX in-cylinder pressure sensors. So that's really good that they've got these setups already ready for you to go. We've also got the ability to add your own probes. And if you want to add your own probes, what you need to do is right click on that arrow area there, click add, and then this menu here comes up for you to set up your own probes. Quite good that it looks like it already has some kind of preset information for you to use and set up your own probes. In fact, just before I showed you that, I wasn't quite sure how to do it. So all I did is hit this question mark down here, and this has got loads of information on how to use the software. So all I did is went to the add and edit probe menu, and it told me how to do it there. You know, really quite easy to use actually. So what I'm going to show you now is this AC coupling adapter. Okay, actually looks quite similar to the attenuator that we were just using. It's obviously just a little case to be able to house the components required. And I've just connected up to a wheel speed sensor, and I'm going to show you what it looks like without the AC signal connected first. So let's just increase that time setting. So we've got the wheel speed sensor on there. Okay. Now this here is kind of typical of a wheel speed sensor. You can see here that we've got a waveform that doesn't go down to zero. Here, look, here's the zero line here, yet the waveform sits above it. Now this one only goes from around about, what is it, 0.5 up to, just move that trigger, 1.4. However, what I find on most wheel speed sensors is that you get a signal at 12 volts. However, the signal only moves by 0.2 volts. Okay, so a very, very small signal. So what we would usually do with that is use AC coupling to bring that signal down to the 0 volt line, and then use a smaller voltage scale so we can actually analyze it in more detail. So if you watch this signal here, it's currently at the 0.5 volt mark here at the bottom. If we then fit that AC coupling adapter, you can see now that the center of the waveform goes here, straight through the middle of that signal. So what that would allow you to do is use a smaller voltage scale to actually see it in much more detail. What we also have is this Zpl mode. Now this is to set the offset just above the 0, and if we press that, what it does is it brings the lowest point of that waveform down to the 0 line, which is also quite a useful feature, and you would probably be able to use it in that same instance. However, I've just connected up to an AC signal, and you can see there that we haven't got that signal going below that 0 line, so you would need to use this AC adapter on the DC mode if you wanted to accurately measure any AC signals. If you weren't really bothered about what the voltage reading was, then it wouldn't really matter to use the AC adapter. You could just connect it up and analyze the signal as it was above the 0 line. So that's a pretty good oscilloscope actually for the price. Let me know what you think down in the comments below. If you've got any questions about the oscilloscope or the software, I'll do my best to answer them. Alternatively, head over to the DITEX website where you can download the software and play with it yourself. You can also go over to mechanicmindset.com and sign up to download those waveforms that I was just playing with.